Hello everyone, and welcome to Adding and Subtracting Rational Expressions. Now in this one, the main thing to remember is that in order to add or subtract fractions, you need a common denominator. Okay, remember that. Back when we were doing normal fractions, if you wanted to add 3 over 5 plus, let's go with 2 over 6, okay, you had to make sure that you had the same denominator. So in order to do this, you would multiply this one by 6 over 6, and this fraction by 5 over 5. And then when you simplified, you had 18 over 30 plus 10 over 30. And you could add these together and get 28 over 30. Okay? Then at the end, sometimes you were able to simplify further. So I could simplify this one by a 2. And my answer would be 14 over 15. Okay, so when you're doing these problems, the same logic applies. If you're adding or subtracting, you need a common denominator. And then after you add and subtract, always check to see if you can simplify. So let's go to the first one. We have, on the one hand, 5 over 4xy. On the other one, we have 2x over 4. Okay, now, but don't get too excited and start simplifying your 2 and your 4 because we need a common denominator, and this one has a 4. So that means we need a 4 in the other fraction. So instead, what I'm going to do is I'm going to multiply this fraction over here times x over y and xy. So now I have 5 over 4xy plus 2x squared y over 4xy. Now that they have the same common denominator, I can put them together, and I have 5 plus 2x squared y over 4xy. Now I can't simplify anything any further because the x's and the y's are wrapped up in addition and subtraction in your numerator. So this is as far as you can go. Let's keep going. Number 2. I'm going to erase this, that way I have plenty of room. For number 2, similar type of problem. Only we're doing subtraction, so keep your eye on the negative sign. So in order to get a common denominator, I'm going to multiply this one by 3x because I already have a y over here, so I don't need to multiply by y. And then over 3x. And then this one over here, I'm going to multiply by 4. Okay, 4 over 4. All right, now in my denominator, I should have 3 times 4 times x times y. So I'm going to have 24x over 12xy. 3 times 4 is 12. Minus, I have 6x over 12xy. Now that I have a common denominator, I can put them together, and I have 24x minus 6x over 12xy. Now I can combine like terms in my numerator, so 24 minus 6 is 18x over 12xy. My x's can simplify, as can my numbers. I can divide both of those by 6, and my final answer will be 3 over 2y. Okay, now let's do a problem where we have expressions instead of just monomials. So in these next few, you can clearly see we have expressions. The main thing with expressions is to keep your eye on that negative sign and to make sure you use parentheses. Okay, it's the same exact logic, we're just applying it now to expressions. So this first one, I have a 6 and I have a 2n, or n minus 2, in my denominator. So I'm going to multiply this fraction by 6 over 6, and then this fraction by n minus 2 over n minus 2. Okay, now because I'm going to end up over the same denominator anyway, I'm just going to go ahead and put it all over one denominator, because it's getting to a point where writing all of this is a lot. Okay, so all I'm doing in my numerator is just putting these things together over the same denominator. So 6 times n minus 2. Okay, and for the moment, leave your denominator factored. Don't put anything together because you may be able to simplify, and you want to have factors in order to simplify. So now I'm going to distribute, and I will get 6n squared minus 12 plus 3n, actually that should be 18, plus 18n, all over 6n minus 2. Now I'm going to rewrite my numerator in standard form. That way I can see if there's anything else I can take out or simplify. Always start off in standard form. Okay, so I'm going to pull a GCF out. I'm going to pull 6 out of everything, so I have 6 on the outside. And now I have n squared plus 3n minus 4. And that will factor eventually. So I'm going to go ahead and do that. And this will break up into 6n plus 4, n minus 1, all over 6n minus 2. Okay, a little sad that the expressions don't simplify, but my 6's do. And then I'm left with n plus 4, n minus 1 over n minus 2 as my final answer. So as you can see, sometimes you can simplify even more at the end. Sometimes it's just a number, other times it could be a full expression. So always make sure you keep things factored as long as possible. On to the next one. So with this, I have 4x minus 5 in one denominator, and then x minus 1 in the other. So I'm going to multiply the other fraction by the denominators. Okay, I'm going to write it like this, simply because I'm running out of room. But please remember that I'm multiplying this term to the numerator and the denominator. Okay, I'm going to put everything over one denominator because it's going to end up there anyway. I now have 3x minus 1 minus 5x times 4x minus 5. Keep your eye on that negative sign. We don't want to lose it. And then in the denominator, I should have both expressions. Now I'm going to distribute. And then when you distribute the second parentheses, take the negative sign with you. So I now have 3x minus 3 minus 20x squared plus 25x. Okay, if you weren't careful with your sign, you would end up with a negative 25 there at the end. So always make sure you are careful with your signs. Okay, now I'm going to combine like terms in my numerator. There actually aren't too many like terms for me to combine. But I'm also going to rewrite in standard form. So now I have 20x squared plus 28x minus 3. And my 20x squared is negative, so that goes up front. Okay, now I'm going to see if I can factor out a GCF. Don't immediately see a GCF that I could factor out with, which means that this is my final answer. Okay, the last few problems. Now, as you can see, it gets a little more complicated, but it's the exact same logic every single time. So as I look at this problem, I actually see that right off the bat, the second fraction can be simplified further. Okay. Now, in the first problem we did on this worksheet, we needed the 4 in both denominators because it was part of the common denominator. In this one, since we're multiplying by expressions, the 3 isn't important in and of itself. So I can go ahead and simplify this just to make my life easier. So then when I rewrite, I have 5 over 10r minus 4 minus 2 over r. Okay? So now when I multiply to get a common denominator, I'm multiplying this one by r, 10r minus 4, and this one by r. Okay, so remember it goes to both the numerator and the denominator. So now I have 5r minus 2 times 10r minus 4 all over 10r minus 4 times r. Okay, now I'm going to distribute in my numerator. Don't forget about the negative sign. So now I have 5r minus 20r plus 8 all over r 10r minus 4. Okay, combine like terms in your numerator even further, and you get negative 15r plus 8 all over r times 10r minus 4. Now, since these terms are close enough, double check to see if there is a GCF, and there is not. There is nothing in the numerator that I can pull out further, and I can't simplify it with the denominator. So that would be your final answer. Okay. Next problem. Now, in this problem, there's nothing that I can immediately simplify, so I'm just going to go ahead and get a common denominator. This one gets multiplied by 2x minus 3, and this is multiplied by x plus 6. So in your numerator, you've got a few things. Okay, use parentheses, that way you keep all of your terms separate. All over 2x minus 3, x plus 6. Okay, now I'm going to factor the first one and then distribute my second term. So this first one is going to be x squared plus 5x minus 6 plus 6x squared minus 9x all over 2x minus 3, x plus 6. Combine like terms in your numerator. I now have 7x squared and minus 4x minus 6 all over 2x minus 3, x plus 6. And that is my final answer. Okay, last two problems. So as I go down here to the number 7, and as I'm looking at number 7, I can see right away that one fraction can be simplified and the denominator of another fraction can be factored out. There's a GCF in that 9n squared plus 18n. So I'm going to cancel out my n's, and then as I rewrite, I'm going to factor out my GCF. So I have n plus 5 over 9n n plus 2 plus 4 over 3. Now, in order to get a common denominator, I need to have the same term in both denominators. As I'm looking, I see the 9 and the 3, which means I don't need to multiply anything to that first fraction. All I need is to multiply 3n n plus 2 to this one. Because when I multiply 3 times 3n n plus 2, I'm going to get 9n n plus 2, and that'll be the same thing. So now I have n plus 5 plus 4 times 3n n plus 2 all over 9n n plus 2. Okay, so now I'm going to distribute my 4 to my 3 only, and now I have n plus 5 plus 12n n plus 2. Okay, and this is simplifying nicely. Resist the temptation to factor out that n plus 2. In the numerator, it is still wrapped up in addition and subtraction, so therefore we can't do that. But what I can do is I can distribute my 12n to both terms, and now I have, I'm going to go all the way up here, and now I have n plus 5 plus 12n squared plus 24n all over 9n, n plus 2. So now all I got left is to combine like terms. And as I combine like terms, I'm going to rewrite in standard form. You're always going to have your answer in standard form. Okay. And there is no GCF that I can factor out of that numerator, and that trinomial will not factor itself. So that is your final answer. Okay, last problem. There is nothing I can simplify first, and there is no way I can factor anything from the start. So now I'm just going to multiply by my denominators. That way I can get a common denominator. Right, with these problems, it's alright if you don't see the right way immediately. Just keep trying, keep persevering, and eventually you will get it. Okay, so now I'm going to distribute in my numerator 4r squared plus 20r plus 2r minus 6. Okay, I'm going to combine like terms. 4r squared plus 22r minus 6 over r minus 3, r plus 5. Okay, I can factor out something in my numerator. I can pull out a 2 at the very least. So I'm going to do that. I'm going to pull a 2 out. So 2r squared plus 11r minus 3 all over r minus 3 and r plus 5. And that is as far as I can go. So that would be my final answer. Okay. Please let me know if you have any questions, and I will see you next time.